Okay, let's try a second example involving energetics and circular motion with this is basically a wrecking ball question. I really recommend you guys try this question yourself first, and then we'll do it together. Okay, so hopefully you tried this yourself, gave it a good effort. Now, we're looking for maximum tension. You have to remember that's going to happen at the bottom of the circle. So logically, we're going to need to know how fast this object is moving down here at the bottom of the circle. We need to know what V is. Then we can find the tension. Let's draw that. Let's also draw the acceleration, so that down at the bottom, the acceleration AC is going to go directly upward. Then for the forces, we have Fg acting downward. Fg is equal to mg. And the tension force has to be much bigger to cause an upward acceleration. And that's why it's called a maximum tension. And then while we're here, let's just put a reference system. Up is positive. Okay. Now, the first thing we're going to have to do is find the speed. Hopefully that was your strategy. Our job, find V. Now to find the V, we have again, we know the beginning, we're looking for the end, beginning, end, something complicated happens in between. That's going to be conservation of energy. So we have the energy total initial equal to the energy total final. At the beginning, this thing is being released from rest. And if we call that bottom height right here, where the height is equal to 0, which makes a lot of sense, then we know at the beginning it has just potential energy. So potential energy initial. At the end, there's no potential, but there is definitely kinetic. So essentially, all the potential energy at the beginning converts to kinetic energy at the bottom. So this leads us to mgh initial equal to 0.5 mv final squared. Masses cancel, even though we know it. And what we'll discover here is that in the end, that V is going to be the square root of GH over 0.5. So 9.81 times the height, which was 1.6 over 0.5. Okay, so let's calculate that. So this is about 5.603 meters per second. Okay, so that's the speed. I'm just going to put that on there. So this becomes equal to 5.603 meters per second. And let's just copy this diagram, and I'll use it for the next stage. I'm just going to add a page here. Okay, so now we go to stage 2 to find Ft. So find the tension force, the maximum tension force. So this time we can use uniform circular motion or Newton's second law. We have F net equal to ma. So F net, Ft is going to be positive, Fg is negative, equal to MAC. Get Ft by itself. Ft is equal to Fg plus MAC, which becomes equal to mg plus mv squared over r. The mass of this thing is 400 kilograms. This becomes equal to 400 times 9.81 plus 400. V was 5.603. Don't forget to square that. over the radius of the circle. And the radius is actually the 3.4 meters, the length of the string. Because that's the center of the circle. Up there at the top, there's the center of the circle. And if you wanted me to just ruin my diagram, here's the circle. Okay, approximately, it's a terrible circle. Sorry about that. I don't know if I can do any better. But anyways, it's just getting worse. Okay, so, but then that's the circle, and you can see that the radius of the circle would be the length of the string. Let's get rid of that before anybody sees it. All right, anyways, so that means the radius will be 3.4 meters. Ooh, it's tough to draw those circles like that. All right, and this gives us about 7,617 newtons. Sig digs looks like 3. So this becomes equal to 7.62 times 10 to the third newtons. That did not come out well. Newtons. Or 7.62 kilonewtons. Good. Okay, I think you've seen enough now to be able to handle all the questions that involve energy and circular motion. Good luck on the homework. I'll see you in the next lesson.